Today we are going to talk about relative formula mass, and that's 4.3.12 in the specification. Okay, let's move on to relative formula mass. So a definition is the mass of the whole molecule. So whatever formula you're given of any molecule, the total mass of each constituent added up will give you the relative formula mass. So adding everything up will give you the relative formula mass. Now let's look at an example. Carbon dioxide. As you can see, first of all, it's a balanced molecule and there's one carbon and two oxygen atoms. We need to add these up to get the relative formula mass. So how do we do that? First of all, whenever we're doing this, we refer to our periodic table. Now I've just got some snippets of the periodic table for the carbon and the oxygen there. A few things to be aware of. The bigger number, which you can see there, is 12.01 and 15.99, is always the mass number. The smaller number is the atomic number. Okay, now even if the numbers are flipped the other way around, we should be aware that the bigger number is always going to be the mass number. Okay, now the smaller number is just the atomic number, as the number of electrons, as long as it's neutral. So moving on, what do? We count the number of carbons, which is 1, then we count the number of oxygens, which is 2, multiply them by the masses from the periodic table and add them up. So 1 times carbon is 12, 2 times oxygen is 32, add them up, we get 44. Now let's look at another example before we move on to some exam questions. So if I was to get the relative formula mass of sodium chloride, I'd have to refer to the periodic table, quite handy over here already. So there's the bigger numbers for both. The formula dictates that it's a 1-to-1 relationship, so it's 1 sodium ion, 1 chloride ion. Okay, so let's add them up. So 1 times sodium is going to give me 23. I've just rounded that up to make life easier. 1 times a chloride ion is going to give me 36. All I need to do now is add them up, and that will be 59, and that's the relative formula mass. Pretty simple. Okay, so let's now have a look at some exam questions. Let's practice what we preach. So first one's asking us to calculate the RFM for H2O. Easy way to do this is there's 2 times hydrogen, which equals 2, and there's 1 times oxygen, which equals 16. Add them 2 up, 18. There we go. So let's look at something a bit more trickier this time. Iron sulfate. Okay, iron 2 sulfate. It's a balanced formula. Now that's something we'll look at in a later video, but you know, the formula is balanced. We could work that out, but like I said, we'll look at that in a different video. So iron, there's 1 times iron, let's write that down, okay, which equals 56. I'm getting this data from what's already been given. That's 56. And then we're looking at sulfur. So sulfur, 1 times S, which equals 32, and that's just from the data provided again. Okay, that's 1 times sulfur. And here's the interesting bit. Look at the subscript. There's 4 oxygens, so it's going to be 4 times oxygen. Now that means 4 times 16, which is going to be 64. Okay, now what we need to do is add these up. So punch these numbers into your calculator. I'm just going to do this manually now. 6 add 4 is 10, plus 2 is 12. A bit of quick maths there. And 6 plus 3 is 9, plus 5 is 14, plus that 1 makes it 15, so 152. Now that's what you should be getting, unless my maths is wrong. Just adding them up as we are, and there's your relative formula mass. Okay, that's me done for today. I'll see you later.